Clayton students. This is your teacher in Science 10, Mom Jennifer Lawrence Mendoza. Before we start with our video lesson, I would like you to go to your respective study area and secure your module and answer sheets. So, let's start now. Today's video lesson is all about Boyle's Law. Now, we have the most essential learning competency for this lesson, and that is to investigate the relationship between volume and pressure at constant temperature of gas and amount of gas with the following objectives. Describe the scientific postulates of kinetic molecular theory. Explain the relationship between volume and pressure at constant temperature and amount of gas using the kinetic molecular theory. And lastly, to recognize the importance of Boyle's law in real-life situations. Now, are we all ready to answer the pre-assessment? There are 3 questions for this pre-assessment. Number 1. What law states that volume of a given amount of gas held at constant temperature varies inversely with the pressure? Number 2. If a fixed amount of gas remains constant at 25.0 degrees Celsius, occupies 3.60 liters at a pressure of 1.00 atmosphere, what will be its volume at a pressure of 2.50 atmospheres? Number 3. A gas occupies 1.56 liters at 1.00 atmosphere. What will be the volume of the same amount of gas if the pressure becomes 3.00 atmospheres?
T-minus 30 seconds.
Get ready with your answer.
T-minus 20 seconds. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Answers for the pre-assessment. Number 1, the correct answer is Boyle's law. Number 2, it's 1.44 liters. Number 3, it's 0.52 liter. Now, don't worry, students, if you fail to answer these questions correctly, because these are just part of the pre-assessment, wherein your scores are recorded but not graded. So let's continue with our lesson. Now here's my question for everybody. What is Boyle's law? Now, have you heard about Robert Boyle? Do you know what his significant contribution is? You know, my dear students, every general chemistry student learns of him as the person who discovered that the volume of a gas decreases with increasing pressure and vice versa. That is the famous Boyle's law. Now remember that gas can be found around us. It is part of our daily living, as there are tools which we use to apply some principles governing gas properties. Do you agree with this? Here are some of the principal general properties of gases which may be listed below. Gases are incompressible. Gases fill any container that they occupy. Different gases mix completely. Gases expand in the presence of heat. And lastly, gases do not settle in their container. Let's continue. Before we can fully understand what Boyle's law is, it is important for us to learn about the kinetic molecular theory, or the KMT. It says in this theory that gases consist of tiny discrete molecules, each of which has a mass. In gases, these molecules are relatively far apart, with empty spaces between them. This is why gases can easily be compressed. Furthermore, gas molecules are in constant rapid random motion. They move in straight lines until they collide with other molecules or with the walls of the container. This movement explains the filling of containers by gases and the mixing of gases. The moving gas molecules exert pressure in the container. A given pressure is the result of the number of such collisions in a unit of time. Now, there are 5 scientific postulates of the kinetic molecular theory, or the KMT. Number 1, a gas consists of very small particles, each of which has a mass. Number 2, the distances separating gas particles are relatively large. Number 3, gas particles are in constant rapid and random motion. Number 4, collisions of gas particles with each other or with the walls of the container are perfectly elastic. Number 5, the average kinetic energy of gas particles depends only on the temperature of the gas. Gases have higher kinetic energy at a higher temperature and lower kinetic energy at a lower temperature. Now here's the main focus of this lesson, Boyle's law. It states that volume of a given amount of gas held at constant temperature varies inversely with the pressure. We have this equation, P1V1 is equal to P2V2, where P1 and V1 represent the initial set of conditions for the gas. The P2 and V2 represent the new set of conditions for the gas. P1 is the initial pressure, P2 is the final pressure, V1 is initial volume, V2 is final volume. The graph. This graph shows a graph of pressure and volume. Kindly note that as the pressure increases, the volume of a gas decreases, and as the pressure decreases, the volume increases. So if there is a decrease in the volume of gas, air molecules will have less space to move. Therefore, molecules will strike the walls of the container more often and will result to a greater pressure. So this is the relationship between the volume of a given quantity of gas and its pressure. So this is a relationship between the volume of a gas and its pressure is expressed by Boyle's law. This law states that the volume occupied by a gas is inversely proportional to the pressure if the temperature remains constant, meaning at constant temperature, if there is an increase in pressure, volume will decrease. Now, if there is an increase in volume, pressure will also decrease. Now, let me show you the units for measuring pressure and volume. Just look at it closely and try to remember the different symbols. Atmosphere is ATM. Millimeter of mercury is mmHg. Torricelli is torr. Pascal is PA. Now, 1 atmosphere is equivalent to 760 millimeters mercury. It's also equivalent to 760 torr or torricelli. It's also equivalent to 101,325 pascals. Now for the units for liquid measurement, of course, with the milliliters or ml, cubic centimeter or cm cube, and liter or capital letter L. Now, since we have already an idea on how volume and pressure are related, why not try to solve a problem involving these two? So we have a sample problem here. What volume will 500 ml of gas initially at 25 degrees Celsius and 750 millimeters of mercury occupy when condition changes to 650 millimeters mercury at the same temperature? So we have our solution. Okay, so we have to consider first the temperature here is constant. Therefore, we can use what law? Definitely it's the Boyle's law. So the P1 here is 750 millimeters mercury. Our V1 is 500 ml, and final pressure, or P2, is 650 millimeters mercury. So this table shows the values, and these are taken from the problem here, letter A. Our focus is to solve for the final volume. Then using the formula for our Boyle's law, which is P1 V1 equals P2 V2, or you can also write it this way, P2 V2 equals P1 V1. Since we are looking for the value of V2 or final volume, then we have to use this one, which is also similar to the first equation here. So P2 V2 equals P1 V1. We divide this equation both with P2 or final pressure. This also here on this side. So we come up with the formula V2 is equal to P1 V1 divided by P2. Now substituting the given values for initial and final pressure and volume as reflected in the table above, our equation would be V2 is equal to 750 millimeters mercury times 500 ml divided by 650 millimeters mercury. We cancel the unit mmHg by slashing this unit out. So we have 750 multiplied by 500 ml divided by 650. We come up with the final answer, which is V2 is equal to 577 ml. Now for your activity, using your notebook, you're going to solve the problem below and show your solution. What volume will 400 ml of argon gas initially at 30 degrees Celsius and 725 millimeters mercury occupy when condition changes to 650 millimeters mercury at the same temperature? What are the several applications of Boyle's law that greatly helped us, especially in the field of medicine? I would like you to think about this. One of the direct applications of Boyle's law is seen in a chest respirator. This is a machine used in the treatment of patients with respiratory difficulties, especially those people who are having difficulty in breathing. Now, when the pressure inside the respirator is decreased, the air in the lungs expands, forcing the diaphragm down. When the pressure of the respirator is increased, the volume of the air in the lungs is decreased, allowing the diaphragm to move upward again. This alternate increase and decrease in pressure enables the patient to breathe even though he or she cannot control the movement of the diaphragm muscles. So we have the first one. It is actually used in a chest respirator. Another is in the use of sphygmomanometer. It is a device used to measure BP or blood pressure, wherein the rubber bulb is squeezed, and when it is done, of course, the volume of air in the bulb is decreased and its pressure is increased. This increased pressure is transmitted to the cuff. Again, here, Boyle's law is being applied. Oh, this is a picture showing a patient with COVID-19 being treated with the use of chest respirator. It's actually commonly used nowadays, especially in this time of pandemic. Another is the sphygmomanometer, a device used to measure blood pressure. For you to monitor whether you have a normal blood pressure or not, you have to use this kind of device. Done. This time is the exciting part, the problem solving time. We are going to solve these problems using the Boyle's law. For number one, the pressure of a sample of helium in a 1.00 liter container is 0.988 atmosphere. What is the new pressure if the sample is placed in a 2.00 liter container? Number two, air trapped in a cylinder fitted with a piston occupies 145.7 ml at 1.08 atmospheric pressure. What is the new volume or V2 of air? The pressure is increased to 1.43 atmospheres by applying force to the piston. It's time to reveal your answers. For number one, the correct answer is 0.494 atmosphere. Number two is 110 milliliters or 0.110 liter. We're done with the video lesson for this day. But before we finally end, I would like to end this with a quote coming from Robert Boyle. According to him, God would not have made the universe as it is unless He intended us to understand it. I hope you've learned something from our lesson. Thank you. God bless you and keep safe, everyone. Goodbye.